Anushka Patil. I'm a data scientist at Sway AI, and today I'll be showing you a workflow that I've created for loan charge-off detection. Let me start by sharing my screen. Yeah. So here is how the portal looks. This is the Sway AI portal, and I've already created some workflows for you. But if you want to create your own workflow, you can just click on create new project, and then you can select whether you want to work with the already created workflow template or whether you want to build your own workflow. So if you want to suppose use a workflow template, you can just click on workflow template. Then you can select some data, the type of data that you're working with. So it could be tabular or audio. So those are currently supported on a platform. If I click on tabular, so you'll be shown the different types of workflows that we currently have. One is classification, which I'll be showing you today. Then there's also a time series forecasting option where you can forecast demand, revenue based on historical time series data. Then we also offer clustering workflows, which can be used when you want to segment products or customers based on similarities with each other. And then there's also a regression or which we call as forecasting option, which is used when you want to predict a continuous value, such as maybe predict the housing price in a particular area or for a particular house. So I've already created a workflow for you, which is the loan charge-off prediction workflow, which is a classification workflow. It's classification because we want the model to classify as either the loan would be fully paid or the loan would be charged off. So this is the workbench view. You can see the data sources, the data preparation steps that were followed, as well as the models that were trained here. So you can ingest the data from different sources. I clicked on data source, and you can either select the sources from where you want to ingest the data, such as Snowflake, AWS S3, BigQuery, Databricks, MongoDB, or you can also upload a comma separated file or Excel files here. Or you can also choose from existing data sets that were already uploaded on the Sway platform. So today we'll be working with loan CSV files. So I've already ingested the data from CSV files. We have 3 different data sets here. One is for loan details, borrower details, and credit details. So when I click on loan tabular data, you can see that it's a tabular data, the extension, it's a CSV file, and you can also see the size of the file. So we offer preview options for all the data pre-processing steps as well as for all the data sets. So when I click on preview data button, you can see the number of columns, the number of rows, percentage of valid, mismatched, or missing values within the data set. So since this is a preview, you can see the top 1,000 rows within the data set. Yeah, so within the loan data set, we have loan ID, loan amount, rate of interest, installment, purpose, the date the loan was issued, etc. columns. You can also click on column view. This is basically the inference for the data. So you can see the percentage, the quality, the data type for each column. If it's a numeric column, then the range, mean, variance, standard deviation, percentage of missing data, as well as outliers. Of course, the range, mean, and variance won't be available for the categorical columns here. Similarly, we can also preview the borrower data. It is 2 MB data set. It is also a CSV file. And here we have loan ID, member ID, basically all the details related to the borrower, such as employment length, employment title, home ownership, annual income, debt to income ratio. Yep. Let's take a look at the credit data set. So this data set has all the details related to the credit scores and credit details for each member. So, which is why we have member ID here, the earliest date, the earliest date for when the credit line was opened for that particular member, number of open accounts, total accounts, um, revolving balance, which is the total outstanding balance for all credit lines. We can also go on column view and we can see that there are 9.3% missing values here. And in order to check which columns have the missing values, we can go to missing data and yep, the last three columns, which is revolving balance, total account, and credit scores, have missing values. So after this, we go on to the data prep step, which is where you can clean the data and do any transformations on data so that it can further be passed to the models. You can click on the plus sign here and you can basically select the data prep process that you want to follow, or you can click on data prep button here and you'll be shown all the data prep tasks that are supported by the platform, such as joins, imputation. You can drop columns, you can select the columns that you want to use, you can drop duplicates, you can filter the data based on a certain criteria, etc. So to begin with, first I will join the loan and borrower data. So you can select the left data set, the right data set here, and you can select the method that you want to join. It could be inner, full, outer, left outer, and then the columns from the left data and the right data that we want to include in order to join. I have selected left join here because I don't want to lose on any of the loan details. Now, once I have joined the data set, I also want to include the credit details here, which is what I'll be joining. And the left data set would now be the previous output that we got from the joint data set. And since credit data set did not have a loan ID, we'll be joining this on the basis of member ID. We can preview the data at every step of data prep process. So now we see we have total of 23 columns, out of which 9.3% of columns have missing values, out of which 9.3% of data is missing. So now we can go on to imputation. Let's see. So the input to this particular data prep node is the output from the previous join step, and revolve val, total account, debt to income ratio, credit scores have had missing values. So we are going to impute that. Now there are different options for imputation as well. You can either impute all the missing values with -1, 0, or you can impute them with mean, median of that particular column, or the last and first values within that column. We can also impute categorical variables, but then the imputation method would be different. We could impute them on the basis of most frequently occurring value, or the past value, or the next value. After imputation, let's preview. After imputation, we should have 0% missing values. Okay, great. Now there's also a custom SQL data prep mode that is offered on the platform, which comes in handy when we want to bin the data, create a new column by running some analysis on different columns. So what I'm doing here is I want to, since the machine learning algorithms that we're using today do not work with date columns, so I have used that date columns to give me the number of months. So issued date, I'm getting the issued months from that, as well as earliest credit line, I'm getting the number of months passed since the earliest credit line was put in place. Yep. And after this, we should have two more new columns for issued months and earliest credit line months. Yes, we have 25 columns now, and we have issued months and earliest months, which are floats. Once this is done, we also want to drop some columns, like we created issued months and earliest credit line months from the date column. So we don't need those now. So we can drop all the columns that we won't be including in the training process. We also have an option for exclude columns. So the difference between drop columns and exclude columns is you would still have loan ID and member ID, which are the excluded columns in the final output. So these columns would still be included in the final view that you have from the prediction, but these won't be included in the training set. Now, once I'm sure that this is the data set or this is the input format that I want to give to the models to be trained, we can select the training model that we want to use. It could be XGBoost estimator, it could be random forest estimator, it could be gradient boosted trees estimator, logistic regression, basically all the classification models that are supported by the platform you can see here, and you can choose that particular model. I'm using GB trees estimator and random forest estimator here. So when you click on the model, you can give it you have to specify the data that we're giving it. So we are giving the model exclude columns. That is the data set from the exclude column data prep node here. You can provide a name for the model. If there are a lot of hyperparameters involved, you can just click on auto hyperparameter tuning and the model would give you the best hyperparameters. Then the train test split, how much data should go into training and how much data should go into testing. You can provide this as well. And then the target column. So loan status is our target column. Once we've selected the columns that you want to train, you can just click on train and evaluate. You can either select a model from here, or you can just select the training ready model that we already have, and you can just train the model. Once the models are trained, you can see the model matrix here, which is, okay, the status, the model is trained. What is the evaluation matrix? So if it's F1 score, what is the F1 score for train as well as test set? And it's very easy to compare the models as well. I'm just going to click on compare. And we can see the values for the GB trees estimator here. There were 16,000 columns. There was 16,000 rows in training set and 4,000 in test set. And if I want to compare, I'll just select the random forest estimator version 1. And you can see a side-by-side view of the evaluation matrix for both the models. Yeah, so these are the evaluation matrix for random forest, and these are the evaluation matrix values for GB trees estimator. So as we can see, both the values are quite comparable. For random forest, the F1 score is 97%, while it's 98% for GB trees estimator. We can also see an ROC chart. Ideally, it should be close to 1 here. So for GB trees, it's closer to 1 than it is for the random forest estimator. Also, both of these models are tree-based models. So they give some weight for each of the features or each of the columns that were included in training process. So let's see so it's very easy to view the feature importance that was provided for each column by each model. So for GB trees, we can see that about 0.57% feature importance was provided to rate of interest, followed by term, credit score, debt to income ratio, annual income, and installment. Let's see random forest. Random forest includes more features. So as we can see, rate of interest, credit score, term, debt to income ratio, annual income, installment, loan amount, purpose were given a lot of importance for training. So once that is done, we can run an inference. So once your model is trained and you want to test the model or test the workflow, you can just click on start inference. You can select the model that you want to test. Since random forest included more features in its training, so I'll and provided more weight for different features, I think I'll go with random forest. You can give it a task name, that is an inference name, so that you can identify different inference results and you can just click on go. I have already created an inference for you with the random forest charge off, estimator charge off. And as we can see, it makes very easy to create a dashboard. So 510 out of 10,000 loans were charged off, while 9490 were fully paid. The total loan amount that went into charged off loans was about $14 million. We can also see or visualize the purpose for charged off loans. We can see that 39.8% of charged off loans were taken for the purpose of credit card, 20% for debt consolidation, 18.2% for home improvement, 11% for small business, and 11% for major purchase. Then we can see the verification status for charge-off loans. About 37.6% of charge-off loans were not verified at all, while 29.6% were verified and 32.7% were source verified. We can also create bar charts. So as we can see here, the average interest rate for loans. So the average interest rate for fully paid was comparatively lesser than the average interest rate for charged off loans, which was 0.17, while for fully paid it was 0.11. Similarly, the average credit score for charged off loans was lower, that is about 600, close to 600, compared to fully paid, which was close to 700. Finally, we can also see a tabular view of the results. So so the data prep process where we excluded the columns, we can still see the excluded columns here, but the columns that were dropped, we cannot see those here. So if I want to see, I can click on explain button and I can see that what contributed to the model making a prediction. So we can see that the installment value and how did it contributed positively towards getting the final prediction, which is fully paid, and the confidence was 96%. So we can see that the model was, the confidence for charged off was 0.04, while the confidence for fully paid class was 0.96, which is why the model predicted it as fully paid. Similarly, if I want to take a look at some other value, we can see here that the rate of interest or credit score values negatively influenced, while all the other values were a bit positively contributed towards the confidence, resulting in the model being 84.8% confident that the particular loan ID was for a charged off loan. Once the inference is done and you have viewed the data, you can also download the results. So it's very easy to download the results. You just click on menu and then you can export the results to a CSV format. So whatever the predictions were made by the model, you can export those into a CSV and you can view them later, use that later for creating visualizations of your own. You can also add more visualizations here by just clicking on customize, giving it a widget name, and then you can create a bar chart, a donut chart, a top area widget, which is what you see here, or a stack bar chart. Yeah, so that is the loan charge off workflow for you. Hope you liked it. Thank you.